Hi 1T1. In this pre-recorded lesson, we will be looking at our workbook corrections, mainly finishing off Chapter 7, Water Pollution, and then also going back to our Chapter 6 on Water Solutions and Suspensions, which you have already done, but I have not gone through the answers. So in this video, I will be going through the answers, and you should be having your green pen by your side, and you should do the corrections as we go along together. Alright, so let's start off with where we have left off for Chapter 7. So please turn to your Module 2 workbook, page 87. We will begin with where we left off, which is Section B, the short answer and structured question. Okay, question 1. Water has properties that make it very useful. These include, number 1, water is a universal solvent. So we have learned that water as a solvent means that it can dissolve many substances. And at this point in time, I just want to remind you of what we have learned in Chapter 6, where solutions is basically equals to solute plus solvent. Okay, a simple equation to summarize what solutions is about. Next, water can also remove heat from objects to cool them. Question 2. The 4 national taps of Singapore are, number 1, local catchment area. So for instance, things like the reservoirs, as well as rivers, like Singapore River, Kallang River, and so on. The second national tap of Singapore is imported water from Malaysia. So the big white pipes that runs between Malaysia and JB. Thirdly, recycled wastewater, or we call it new water, a national tap that we should all be proud of because it's Singapore's technology. And then finally, desalinated water from seawater. Okay, so the process of desalination basically is to remove salt. Question 3. To reduce the effects of water pollution, we can, number 1, clean up polluted beaches and rivers. So this is done through our programs like the Values in Action, VIA program. Secondly, we can provide bins along the waterways because we do not want people to litter on our streets, so as well as waterways, so we can provide rubbish bin for that matter. And finally, we can clear rubbish clogged drains as well as canals. Okay, so please do your corrections. Alright, now that we have completed Chapter 7, let's backtrack a bit to Chapter 6 to look at the revision questions. So again, you should have done this already. So now we are just going through answers and for you to do your corrections. Okay, so alright, so this is Chapter 6, Water, Solutions and Suspensions. We are still at the same workbook, but now please turn to page 57. Okay? Alright, so we are going to go through the revision questions, starting from Section A, multiple choice questions. Let's look at question 1. Okay, so we have Ben, who added some soil to water. However, the soil did not dissolve after some time. He came up with a few reasons to explain why this happened. Which is the most likely reason? So in this case, the answer is B, because soil, it says that soil did not dissolve after some time. Okay, so over here again, let me bring you to your memory of the concept of solubility. So in this case, we say that the solubility of the solute, which is soil in this case, is very low because it does not dissolve even after some time. Okay, quite a simple question. Moving to question 2. A solution is different from a suspension because, so if I were you, I would do all these annotations, right? So as to help me answer the question. In this case, the answer is A. A solution looks uniform throughout in its appearance. Let's look at the other options. Why is it wrong? So B, a solution does not allow light to pass through, that is incorrect. It allows light to pass through completely. As for C, your solution, right, is made up of solvent and solute, in which your solute is fully able to dissolve in your solvent. So in this case, insoluble residue is incorrect. Then moving to part B, the components of a solution can be separated through filtration. This part about being able to separate a solution using filtration is again incorrect because everything has been dissolved fully, so there should be no residue. Question 3, in a X, the solute or solid is Y in the liquid. The mixture appears Z. Choose from the following the best option to complete the above sentence. So for this question, it is most easy to do using elimination method. Okay, so again, if we annotate the question, the main idea is about mixtures, right? The concept of mixtures. So as we know, for suspensions, we say that they are non-homogeneous, meaning not the same. And then for solutions, they are homogeneous. Homo meaning same throughout the solution. So if we look at the options now, options A and B, if your mixture is a solution, okay, then what will happen is that your solute has to be soluble, right? It is able to dissolve fully such that your mixture appears clear. Now looking at C and D, it is a suspension now, so therefore your solute is insoluble, thereby forming a cloudy mixture. Okay, so answer is A. Question 4, you have a spoonful of sugar added to a cup of water. Upon stirring, a clear solution was formed. Identify the parts that make up the sugar solution. This is very easy. The solute in this case is sugar and your solvent is water. So answer is B. Moving on to question 5. Which of the following is or are a suspension? The answer in this case is C. Let's look at the options one by one. Option 1, iced water. This is a solution. Okay, in fact, it's just ice in water. Part 2, orange juice. This is a suspension. So you have the orange pulp and everything that's being suspended. Part 3, salt water. Salt is definitely a solution as we have learned. Flour and water, this is a suspension. So answer is C, option 2 and 4. Question 6. The solubility of a substance in water is, answer is A. This is a straightforward definition question. The greatest amount of substance can be dissolved in a given amount of water. If we were to move on to question 7, you will notice that you are also tested on the concept of solubility. So the solubility of a material is affected by 3 factors, right? As we have learned during class. So solubility, as I have given you a easy way to remember this big word, is basically how much of a solute can you dissolve in a solvent. So the first factor affecting will be type of solute. So for instance, sugar and water and salt and water, they dissolve a bit differently. Secondly, type of solvent. So is it water, is it ethanol, and so on. And then finally, temperature of the solvent, right? If you have hot water, then your Milo is able to dissolve faster. Or rather, you can dissolve more. Question 8. You have 3 liquids which are tested with litmus paper. The following observations were made. So number 1, your liquid X turned blue litmus paper red. Next, your liquid Y had no effect on both blue and red litmus paper. Liquid Z turns red litmus paper blue. Question asks you, what can you deduce about the three liquids? So looking at liquid X, from what it tells us, we can deduce that X is an acid because it turns blue litmus paper red. Liquid Y, on the other hand, has to be a neutral solution of pH 7 because it has no effect on both indicators. And then finally, liquid Z, because it turned red litmus paper blue, it has to be an alkali. Therefore, answer is D. Moving on, refer to the following experiment to answer questions 9, 10, and 11. Beaker X contains small suspended powder particles, powder. Beaker Y is a diluted salt solution. A beam of light was shone through a cardboard with a tiny slit into the two beakers. Which option correctly describes the observations from the two beakers? So this is very straightforward, right? Beaker X is a suspension, so some light may pass through, but beaker Y being a solution, all the light passes through completely. Question 10. The mixtures in beaker X and Y were separately filtered. Which option correctly describes the observations from the filter paper obtained from the filtration of the two mixtures? So one has residue, one does not have. Question 11. The residue observed on the filter paper in question 10 could be. So A is definitely wrong, right? Because salt, as we mentioned, is soluble in water. It's just like how you put salt into your soup when you do cooking, it is able to fully dissolve. Okay, so B is also wrong. In fact, it dissolves even better, right? Because it's in powdered form. C is your answer. Talcum powder, baby powder is insoluble in water. And then finally, sugar is also soluble in water. So answer is C. Moving on. Refer to the following experiment to answer questions 12 and 13. You have Ben who performed the following experiment. In part 1, where he poured 100 cm cube of water at room temperature into a glass beaker, he then added 1 teaspoon of salt into the water and stirred until the salt completely dissolves. He noticed that after repeating step 2 a few times, the 4th teaspoon of salt could not completely dissolve. Okay, a lot of words here, but you should highlight what is important, right? So basically this sentence. So question 12. Ben warms the mixture to 80 degrees Celsius. Okay, so again, underline, highlight. So he did some warming, temperature has increased to 80 degrees Celsius. So what do you expect to observe? Okay, so it's just like Milo, right? You use hot water, then more of your Milo powder dissolves, so less of your Milo powder is observed at the bottom of the beaker. Okay, similar kind of understanding. So therefore, answer is A. Okay, and the factor here is because of your temperature of the solvent. Moving to question 13, Ben now repeats the above experiment with a different solvent, solvent L, under the same conditions. And after repeating step 2 twice, he observes that the salt cannot be completely dissolved. What conclusion can Ben make from his observation? Answer is B. Okay, so you notice that the question stated very clearly that this experiment is done under the same conditions. So the only thing that's different is that it's a different solvent. Okay, and looking at the last sentence, it says that the salt cannot be completely dissolved in solvent L under room temperature. So therefore, you can conclude that salt is more soluble in water than in solvent L at room temperature. So answer is B. Okay, a slightly tricky question, but it should still be manageable. Question 14. Hakim conducted an experiment to determine if an increased temperature of a solvent increases the solubility of a solute. Okay, that's a huge chunk of words, so you should highlight that. He recorded the results of his experiment in the table below. Which of the findings appear to be incorrect? So I would highlight that, put a cross, so that I know that the answer that has a cross is my answer. Okay, so this is simple. You just need to look for trends, right? So as temperature increases, you would expect that you can dissolve more sugar, more solute. But for option C, you see that there's a anomaly. Okay, so that is the answer. Question 15. Su Zheng made 2 cups of tea, 1 cup, 2 cup. The same type of tea bag and the same volume of water were used to make both cups of tea. In the first cup, cup X, you added 1 gram of fine sugar. Okay, so 1 gram fine sugar. And then in cup Y, you also add 1 gram of sugar, but now it is a lump of sugar. Okay, and then both cups were left to stand for 10 minutes without any stirring. Su Zheng then tasted both cups of tea and observed that the tea in cup X tasted sweeter. That simply means more sugar has been dissolved. Which of the following conclusion can be made from the above experiment? So if you're able to draw all these out, it becomes very clear that the factor that is of concern here is surface area. Surface area of the solute affecting the rate of dissolution or the rate of dissolving. Finally, let's move on to section B, short answer and structured questions. Question 1. A salt solution contains water as the solvent and salt is the solute. So again, remind you, solution equals to solute plus solvent. Question 2. Identify the solvent, dissolved solute, and undissolved solid in the following mixtures. So part 1, muddy salt water. Salt is the dissolved solute, soil is the undissolved solid, and water is the solvent. Part 2, fizzy drinks. You have something and something, which are the dissolved solutes. So the first answer is carbon dioxide gas. Basically, the fizziness of your soft drinks comes from carbon dioxide. And then the next one, of course, is sugar, because soft drinks are so sweet. And then, of course, water is your solvent. Question 3, a solution appears clear when a beam of light is passed through it, whereas a suspension appears cloudy and only a small amount of light passes through it. When filtered, a chalk powder suspension leaves a residue on the filter paper. And finally, question 6, your acidic gases, they are able to dissolve in water to produce acid rain. Okay, so here's me drawing a cloud, some droplets of acid rain. Question 7, suggest whether the results of the processes in the table below are useful or harmful using a tick in the correct boxes. So part A, water dissolves chemicals in soil and flows into the rivers. So this definitely has to be harmful, right? It pollutes your water in the rivers. B, in hospitals, some chemicals are dissolved in water and the solution is taken by patients. This is useful because it's used in medication, right? To administer some medicine to people who are ill. C, acidic gases in air are soluble in water. That's harmful. We just talked about it because it causes acid rain. Water is used to flush a spill of soy sauce on the floor. That's definitely useful, right? It helps you to clear up the mess. Okay, question 8. The properties of 3 solutions are as follows. You have solution X, which tastes sour and changes litmus from blue to red. Solution Y has a pH value greater than 7. Solution Z does not affect the color of litmus. Part A, you're supposed to match. So the answer is as follows. Right, so going back to the description, you know that solution X definitely has to be an acid, Y is an alkali, and Z has to be neutral. Okay, part B. Solution X will have a pH value that is greater or lower than pH 7. Okay, again, knowing that it's an acid, it has to be lower than pH 7. And then part C, because Y is an alkali, it will turn red litmus paper blue. All right. Okay, that's pretty much it. We have come to the end of the corrections. Now let me just change to brown color and tell you that that's all, folks. We are done with this part of going through of answers for the workbook for chapters 6 and 7. I will see you in the next lesson. Smiley face. Bye bye.